Hello everyone, welcome back. So now in this video, we are going to particularly cover how to make a fast MCP server and how to create tools, and inside those tools, what parameters are we going to give and how to interact with our own local database. So the goal is to create fast MCP client, then MCP server, and a local Ollama agent to connect with the fast MCP server and the client to call a specific tool based on our own user input query. So this will give a leverage to the large language model to connect with our own tools which we have developed. So first of all, we are using some basic libraries, PsychoPG2, Argon Pass, and the FastMCP. So this library, PsychoPG2, is used to interact and connect with your local databases or your Postgres instance that are hosted on cloud or remotely, but currently we are using our own database that is created in a pgadmin 4. We are using this local PostgreSQL instance database to use a specific table name known as customer information, and this customer information consists of some data which I have dumped it before the demo, and also we will be dumping and inserting some data with our own local uh, large language model using the Quen. So this table consists of some columns: ID, customer name, customer age, customer company, and customer information. So based on these columns, we will be interacting with our MCP tool and MCP server to bring a specific information from our local database. So let's get started. So now we are initializing our FastMCP server by using the FastMCP class, and this class is already defined uh, in Python, which gives a leverage to connect and create FastMCP server. And once the FastMCP server is created, you have to make sure give the FastMCP some server description. So currently we are giving a description of database dash demo. So in this way, our FastMCP creates an MCP server known as database dash demo. So now we are using a simple function to connect with our local database, and this credentials are going to be different as you will be using your own local database instance, and every configuration is going to be different. So I have used my own credentials in order to connect with my database. Then once the credentials are executed, we connect that credentials using the con.cursor, and once it's done, we will execute some query. In order to execute a query, you use cursor.execute, and in that execute area you have to mention your SQL query. So I have executed create table if not exist customer information, some ID, serial, primary key, customer name, columns like customer age and customer company. So this will execute a query. If a table exists, then it won't work, and if it doesn't exist, then it will create a table name as customer information and the specific columns which we have mentioned. So this basic function is going to return us some connection and some database information that whether the table is created or not. Then coming towards the MCP tool, this is how we create our MCP tool. So we write it as @mcp.tool, and this is our first tool, which the tool name is add_data. So this is a simple Python function, and this tool consists of some parameters like customer name, and it requires some parameters like name, age, company, uh, and the type is going to be every parameter will have a type string, of course, and we are giving some comments on the code that it dynamically add a new customer to our database. So this add data tool is going to add some data in our local database, the table which I've shown you, that is the customer underscore information. So if this add underscore data tool is called by our local large language model, so based on our input query, specific information will be added in our local database. So once this tool is defined, then we will jump towards the second tool. That tool second tool is responsible for reading the data from our local database, and it's quite simple to create any tool. You can create different kinds of tool based on your own use cases, but our today use case is to create a database demo, that like how to create tools, MCP server, a client, and then using the llama index orchestration platform to run our Ollama local Quen model to interact with this MCP model context protocol uh, in a communicative way. So once this MCP read data function is created, we will then write a main function where we will be using the parser, argument parser, which is basically responsible for parsing command line strings into Python objects. So uh, once we have written this, then we will jump towards the running our own MCP server. So this is how the MCP server is created. Now if you want to run this MCP server, what you have to do is you can write a command here. Let me show you. You can use UV, which is basically UVCon, that runs your Python application on your local host machine. So UV is used for running your FastMCP server. Let's run this, and this FastMCP server is going to run on a port name which we have mentioned, 8000. This is our port 8000. So if we scroll up, so our MCP server has started running on port 8000 and on a specific mode, SSC. You can so SSC, there are some modes in FastMCP which tells us in which communicative way you want the server to communicate with the MCP client. So we have the SSC mode, then the STDIO mode, and different modes. So the transportation mode in which the MCP is going to communicate with the client is going to be SSC. So our MCP server has started successfully and it is running on the port 8000. Now let's jump towards how to make our own local uh, large language model by using the llama index and importing that large language model Quen into our into our code. So first of all, you need to have the Ollama installed, and Ollama is basically an open source framework. Let's open that Ollama, and Ollama gives us a leverage to use the local based large language model. So in our case, we will be using the Quen large language model, and this is going to be our large language model that will be interacting with our MCP tool. So you need to write this command Ollama list to see how many models you have currently installed on your local machine. So we have the DeepSeek model, Nomic, Quen 3, 1.7, and other Quen 0.5 B model. So the B represent the how many number of billion parameters we have. So we need to run our Ollama we will write the Ollama run command, and we will run this Quen 1.7 billion model. So this model will automatically start running. Let's say hi. So now this model is pre-trained on large corpus of data, and this model doesn't know how to connect with the MCP tool, and it does not know the information about our local database and the tools and the client. So we will be connecting this Quen model with our MCP server. So MCP server is running over here. Now let's jump towards the Ollama client.ipynb Jupyter notebook. So we are using the net asyncio to basically allow some nested event loops. You can use them, and you can also install them by using the pip show, by using the pip install and nest asyncio, and you can see the version. I have the 1.60. Now the next thing we are going to use is the llama index. So llama index is basically an orchestration layer that gives an advantage to a large language model to connect with the MCP tools. So you have to install the llama index by running this command. So once it's installed, you will see that we have a specific llama index installed on our IDE. So this is the version on 0.14.4. Now next we will set up a local large language model, as we will be using the llama index dot ollama and import Ollama. So basically this orchestration layer will directly connected with our Ollama, which we have currently over here, that is the Quen model. So then we will import some settings, and now this is the part where you need to understand how to initialize a large language model. We are simply using the a simple variable LLM, and inside that LLM we are calling the Ollama class client, and inside that we are using our model Quen 3 1.7 billion parameter and a request timeout of 120 seconds. So in this way our large language model has been initiated. Let's run this and see inside that what do we have. So in the large language model we currently have the model Quen 1.7 billion and the temperature which is already been set. We do not need to worry about that, and it's giving an information about a local large language model which we have set on. Then let's run this, and also the settings we the Ollama index the llama index will automatically use some settings which consist of the base URL of the Ollama model on which our Quen model is running. So basically it's running on 11434 port. Then we will install the llama index tools -mcp dependency to basically interact with the MCP FastMCP client server, and in this way we will connect our large language model with the MCP. So you need to install the llama index tools -mcp. Once it's done, now we will initialize the MCP client and build the agent. So we are using the llama index.tools.mcp, and we are importing the basic MCP client and MCP tool spec. So in basic MCP client stands for the MCP client, and in this way you can use the MCP initialize and use the MCP client over here. So we are defining a variable MCP client, and inside that variable we are using the basic MCP client library, and we are telling that basic MCP client that our server is basically running on this port 8000 and the transportation layer is SSE. So in this way our MCP client will initialize, and inside that then we have the concept of importing the tools. To see which tools we have, we will print it on in the next line of code, but in you can also pass list of allowed tools which you have developed in your MCP server side. So once it's done, we will see which tools we have. So we have two tools. One is the add data, that dynamically add the customer information to the database, and the second tool is to read data from the customer information table. We have two tools. Then we are going to write some system prompt for our large language model, that it's a tool calling large language model, and before you help a user you need to work with the tools to interact with our database only. So this system prompt is the guardrail for the large language model to only follow this prompt and do not follow outside of the information in only following the system prompt. So once it's done, our system prompt is done, then we will call our function agent from the llama index, and this function agent is basically going to have some description variables, like for example the agent name, the description for the agent, and the description for the agent is that it's a database software, and the tools which we are going to use, and the large language model, and the system prompt. So the large language model is going to be Quen 1.7 billion model, Quen 3 1.7 billion model. The tools, we have the two tools, and the system prompt is defined above. So in this way we initialize our get underscore agent, and in this way we give all the properties and descriptions of our tools, agent, and the system prompt. So once it's done, we will write another tool calling functionality, where we will be calling our agent and our tools. So we have handle user message in which we are expecting to have a message content in a string, and calling the agent and the agent context and what the context is going to be about. So once it's done, we will jump towards the initializing the MCP client and building the agent. So this step has already been done. Now we need to get the agent. So you have to write the get underscore agent, and in this way it will get the agent with the specific MCP tool. And then also creating a context for the agent so that it remembers the information and the user input query and all the information that has been given to the agent. And in this way it will remember the context, what the context is about, and which tool and which action to take based on the user input query. So now this is done. Our client is initialized, our server is already running. Now we have initialized a while loop where we are basically running the large language model and the MCP tools and the MCP client to send a message in a while loop to what tool to call and what to do. So let's run this, and this will start. So now our Quen 1.7 billion parameter model is running, and it is successfully being initialized. So let's in this while loop, let's pass a message and see what the Quen large language model is going to do and how it is going to call our different tools using the MCP server inside that the tools, and how the large language model is going to bring the information. So let's say give me all the information about customers. So currently right now our Quen model is uh, first thinking, then calling the specific tool. So it's going to read that tool data. So it has called the tool, that is the read data, and it successfully returned us all the information about the customers which we have currently in our database. So this is the list of the customers with their details. So when our large language model successfully returned a very accurate result based on the information stored in our local database. So now this is how our Quen large language model is using the power of MCP, model context protocol, and it's using the tools, calling a specific tool based on the user input query, and also maintaining the context of the whole information. So let's, for example, I want to add a new record in my database. I want to add a new customer named as John, and its age as 29, and its company, which is AI Labs. So in this way the Quen model is going to first think to which tool to call, and then add that specific information in our local database. So this is a power of model context protocol, which enables a large language model to connect with external, internal, or different tools you have on your own ecosystem. So it's going to take some time because it depends upon your GPU, your and your local machine, that how much memory you have. So let's see how much information the Quen model have done. So the Quen model successfully added the John value in our local database, and it successfully called the read the add data function. So in this way you are going to develop your own local based Quen model, your own local based MCP model context protocol agents, and in this way you can connect with any CRM tools, business application tools, using the model context protocol. So I will be sharing the source code with you, where you will have more detailed information about how to create the client, how to create the server, and how to create your tools by connecting those uh, tools with your local databases or on-premise or cloud databases. So cloud Anthropic gives us the leverage to use MCP to communicate with different tools and different ecosystem environments for AI engineers or software developers or different companies who wants to adapt the concept of model context protocol. Thanks very much.